So the HTTP protocol is what allows us to access and browse the internet. It normally lies under the hood and is managed by websites and our browsers. But as bug bounty hunters, we need to dig deep into those HTTP requests using something called HTTP proxies in order to view and analyze them. And that is a skill in itself, and understanding how HTTP requests work and look like is the topic for today's video. And I'll break down what a HTTP request is and what it looks like. I'll also show you how you can set up your HTTP proxy and which one you should use. And then I'll also go into some of the smaller quirks of HTML just to give you an understanding of some of the vulnerabilities that you can find there. Now, before I get into the main part of this video, I want to show you what HTTP proxies you can install so that you can follow along with the rest of the video. And the one that I personally use is called Kaido. And Kaido is really good for analyzing HTTP requests passively as they come in, and I'll explain what that means in a minute as well. Well, to download it, really all you need to do is click this download button, and I think you'll be prompted for your platform here. In this case, downloaded it for Linux. But once you install that and you open it, you'll get a screen like this. And the simplest way to use Kaido is just to use their browser here. So I'm just going to launch it from Chromium right here. I'm pretty sure this comes included with it. So you'll just get this browser and you'll be able to use the proxy from here. Alternatively, you can also set it up for Firefox, which is the way that I use it. I have an external browser running in Firefox, and then I imported the certificate into Firefox. And that gets a bit more complicated, and I'm pretty sure you can find it somewhere here. Yeah, somewhere in their about section here anyway. Well, once you I recommend only doing that once you play around with the browser a little bit, especially if you're newer, and it's better that you start off with their browser and then you can start modifying it yourself. And the second option is called Burp Suite. Burp Suite is a much older HTTP proxies, and it's more good for active testing. So looking at a HTTP request and then modifying it like directly, and then performing some of the more classic analyses. And this is, you definitely can't go wrong with this either. I prefer this a little bit less, mainly because of the UI. It's a bit ugly in my opinion, but you can definitely use Burp Suite as well. It's a bit more actively developed, and it definitely has a lot more features. So in that sense, Burp Suite is very good. It is kind of expensive though, especially the professional version. The community version does work quite well, although I think it is a little bit worse than Kaido as well. So you can make a choice between two of these. Here you just enter your email, and I imagine you get like a download link. You can do the same. You can either use the built-in browser or you can use Firefox for your proxy. And once you have your proxy installed and running, what will happen is basically once you visit a request, so once you use a, okay, for example, from here, from Kaido, right? If I open up Chrome, so if I turn on the forwarding here, and I think I have this set to a scope, so I have to turn that off. Say like test or something like that. You'll see my request is being captured, question mark? Yeah, right here. You can see that my request has been captured. So you'll be able to inspect the HTTP requests that are used to navigate the web, which is very interesting. So that'll give you the tools to actually start looking for vulnerabilities. Okay, with that said, I hope that you have your HTTP proxy configured now, and that you can now have a look at the requests that are coming in. Now that you can do that, I'm going to break down what they look like and what each of the words in the HTTP request actually mean. So I'm going to turn on the forwarding here, and I'm just going to refresh this page right here, right? What I'm going to do is I'm going to right click, I'm going to click send to replay and default collection. That will just allow me to have a look at it in a more confined environment here. Okay, so let's start with the first part, the request method. There are 5 main methods to HTTP requests, and they are get, post, put, patch, delete. And that's going to be the first word you see right here. So these kind of determine what the HTTP request does. So get request is normally used to fetch a resource from the server. And in this case, I'm fetching the HTML for the root directory here, which means the slash. And I can also fetch something like JavaScript files, which are normally static, or I can, for example, fetch my credentials. In general, when there's a GET request, that means that the server is going to return something to me. Now, there's also a POST request. And what a POST request does is it generally performs some kind of action. So, obviously, I haven't coded in anything, this is just a sample website. But what a POST request will do is, for example, I could use a POST request to change my username. I could use a POST request to create a comment. I could use a POST request to, I don't know, update my credit card information. Something that actually performs a physical change on the website is generally going to be called a POST request. And POST requests normally have a request body, which we will also get to in a minute. The other three requests, they're not official HTTP methods, but they're often used by websites. So put is used to modify data, or post is normally used to create data, especially in APIs. Patch can also be used to modify data. Put and patch are kind of the same thing. And then delete is used to obviously get rid of data. So those are the 5 HTTP request methods. And then the next value here, this little slash, is the directory that we're sending the request to. So if you see back to my website, currently I've sent it to this directory. But if, for example, there's a directory somewhere else, like, for example, like test.php maybe, there's some directory like this, then if I now go here, if I intercept that there, like so, you can see that it's instead sending it to this directory. And the slash just means basically the start of this. So this part gets cut off and we're just left with this. And the request sort of automatically knows it's going to that website, right? So we can send it to whatever directory we want. And the servers will route it differently to different code depending on what directory here we specify. And in this case, it's not found because it doesn't exist. And then we have our host. Now, it's going to require a little bit of explanation. So the host specifies what server, not what server, but what part of the server our request is being sent to. So what normally websites look like nowadays is that we have our server, right, which is the main one, and our server has an IP address, say like 1.1.1.1, a 4-digit IP address. Instead of using the whole server as one website, what most companies do now is that they expose ports on the server. These are like small like bits that you can access, and they're indicated by these two commas. For example, port 80 is normally what's accessed for a website, right? That's the normal port reserved for HTTP. Could have something like port 500, port 6000, and it goes up to I think 64,000. So that's a lot of ports, right? And essentially, each server usually exposes more than one port, and you don't really want the main HTTP server to be running on the main port, right? So instead of that, what a lot of companies do is they indicate this host header, and then using a proxy, they route the request to a different port. And that sounds very confusing. So maybe I'll explain it a little bit better. Right? I'll just get rid of this. So this is our HTTP request coming into the server, and it's being sent into the IP address of the server, so 1.1.1.1. Then there's a proxy in between. So the proxy then decides, depending on the host, what port to send our request to on the server. So in this case, we've routed it to jacobjnbookbounty.de. So it's going to ask the server, what port are you hosting this host on? And the server will respond with the port, and the proxy will then send that to the corresponding IP address. For example, that could be like 1.1 dash like 400, let's say. There could be another website hosted on a different port. And if we change the host, for example, we could end up somewhere on like 800. Let's just say there's a different website, like mail.jacobjn/bookbounty.de. That could be a different website hosted on a different port. And because DNS doesn't actually allow you to specify ports, it's just an IP address, then that's how the server will route the request to the correct port. That's very confusing, and it took me a long time to understand that. So you can do a lot of further reading on that as well. But that's the basics of it, and the host basically just controls what port a request is essentially going to be sent to by the proxy. Don't stress too much about it anyway. So the user agent, that just specifies what browser we're using, and the rest of these headers aren't very important. Accept header, just what information the browser is accepting. These are completely useless to us at the moment. So are honestly all of these. And we're going to get to this cookie header here, which is going to be the next really important one, because it's how the browser stores credentials in our requests. So when we log into a website, what normally happens is that the server will set us a cookie that allows us to be logged in and not have to log in after each request. Because HTTP requests themselves, as you can see, they are stateless. They don't carry any information about the user. None of that is included. So we have to send them in with this request. That request will include a cookie, which allows us to stay signed into a website. You've probably seen it before, where a website asks you if they can use tracking cookies or something like that. So it's basically something that stays appended to your HTTP request when you're sending it to that website. So if the website gives me a cookie, then every time I send a HTTP request to that website, my browser will append the cookies to that request. That allows a sort of user session to continue to exist, even though the HTTP requests themselves don't actually allow for any states to be set. That's very important to understand as well. And that's essentially it for these GET requests. And then the next part is going to be the POST request bodies. So a POST request also normally has a body, and that is basically the information after the headers. These parts are called the headers, and then the part after is going to be called the body. And the body is the information that we're sending the server. So normally that's if it's a POST request, that's going to be some kind of information detailing what we want to create. So back to the comment example. If we want to create a comment, then we have to send a body which has the text for the comment. And then the server will take that body and then create a comment with our text. That's how that POST request will work, for example. So it will always be after the request body. And then what we have to specify as well is a content type header and a content length header. So content type tells the server what kind of content it is. So what kind of like file it is. So if you have your computer, you have like a .pdf file, you have like a .text file. That tells your computer what file type it is. And it's the same thing with our HTTP request. We need to include some kind of like file type so the server knows what to do with the information. For example, you could say text/plain, which a text/plain is the simple .txt file. It's just going to be text, right? And the server will process it as text. And we can include a lot more of these. For example, there's JavaScript, there's XML. Really, any file type you can create can be changed to a HTTP request as well. And then the second part is the content length header. And content length just specifies how long the content is. That's it. And it specifies it in bytes. So I think in this case, that's just 4 bytes in that case. So that's how long the content length would be. Some servers don't actually need the content length because they process it anyway. But for it to be correct, you usually need this content length header. So that's what that means. So that's the bulk of the HTTP request. Now I want to talk a little bit about the response as well. Now, the response is quite similar to the request, but instead of specifying a directory, the response actually specifies a status code here, right? The status code tells us basically kind of information about what the response did or didn't do. So a 405 response means that the server doesn't allow that kind of method in this case, right? So I sent a post method to a directory that doesn't accept post requests. And when it starts in 4, it means that there was an error. Something like 405, 404 means that it wasn't found. 401 means unauthorized. And if I, for example, go back to just the regular GET request here, like so, you'll see a 200 request. So 200 requests usually means that the request was successful, that the request went through correctly, and that everything is working fine, right? And there are loads of these HTTP request status codes as well. So 200, 300, 400, and 500 is I think what it goes up to. And you can find them all on MDN docs. You can Google them online. It took me a while to get used to them as well. So if it's your first time looking at a HTTP response, then it might be unfamiliar to you. The word 200 might not mean anything, but you've probably seen the word 404 before. It's a quite common expression used now as well. Many websites use it, so you can get used to using these status codes, and after a while you probably won't even need to use any documentation for it. So the next part is the server, and that tells us what server the website is running on. In this case, this is usually going to be the proxy that sent the request. So if you remember in that diagram, HTTP request gets sent to the proxy sends it to the server. In this case, the server here, the value is usually the proxy. And Nginx is the reverse proxy that I use to host my servers. So I have this running on like port 5000 or something, and then Nginx just forwards that request to the server into the appropriate port. There's normally a date contained here, a content type, which, as I explained before, we have a response body here as well. So that specifies what file type our response body is. So it tells the browser what to do with that information. And the rest of this is kind of unnecessary, so you don't need to know about it now anyway. And then you have the content length. Obviously, it does the same thing as in the request content length header as well. So that's pretty much it for the HTTP request responses. What I wanted to talk about anyway, and I hope this will give you a much better understanding of how HTTP requests work, so you can start analyzing them and finding vulnerabilities. Common vulnerabilities you might find here, for example, is if you have a post request and you have like a body here, you have like, for example, ID is equal to 1, and then you're editing a comment, for example, with the pull request or something like that. If you change the ID to 2, maybe you can edit like someone else's comment. Could try that. And there are much more complicated vulnerabilities, too much for me to list anyway. But with the HTTP proxy, you can actually start looking for the real bugs by just using a mouse and keyboard to find things. You can actually delve deep, and you're not using something like the Chrome Dev tools, which is just awful. But anyway, I hope that this video cleared up some of the confusion you might have had about HTTP requests and how they work. And if you did enjoy this video, let me consider liking and subscribing to the channel, and you can watch my previous essentials video on understanding HTML, which is one of the file types that often is one of the responses by the server, and we can actually find vulnerabilities in that file type depending on what the server returns to us and depending on what we send the server as well. So I highly recommend checking out that video if you're not familiar with bug bounty, if you're just getting started and you want to build up some of the foundations. And as always, thanks for watching and happy hunting.